Welcome to you, my viewers and my subscribers. Welcome to another video. This is JK Engineering and Architecture, where I cover engineering, architecture, as well as construction topics. So in my last video, I have went over a simple example just to clear up my previous example of how to calculate the duration of your construction project as well as your critical path. So therefore, in this video, I am going to do a topic on resource allocation and resource leveling. Now, resource allocation and resource leveling is just a measure of how to properly utilize your labor force on your construction project. You do not want to overburden your construction project with too much laborers that is not necessary to complete a particular task. So therefore you want the right amount of labor force to complete your task on your construction site so as to cut back on your labor costs. So this video is going to demonstrate to you how you can properly level your resources and put you in the right path of how to cut back on your construction costs in terms of labor. So as it is, the topic is resource leveling and resource allocation. So resource allocation is the assignment of the required resources of each activities in the required amount and timing. So you're going to allocate the right amount of resources in terms of the amount and timing to get that particular activity finished on time. Now, resource leveling is minimizing the fluctuation in the day-to-day resource use throughout the project. So let me go back over that one more time. Resource leveling is minimizing the fluctuation in day-to-day resource used throughout the construction project. So I have covered what resource allocation mean and what resource leveling mean. Now in this exercise, I'm going to show you a somewhat real-life example, a more realistic example. So imagine you are a contractor and you're given a small project to go to an existing building and replace the old tiles with new tiles. So the chart is set up like this. So you have in the activity column, you have activity A, activity B, activity C, activity D, and activity E. Now, the activity description, so activity A is purchase and delivery of material. Activity B is removing existing tiles. Activity C is installing new porcelain tiles. And activity D is painting and installing windows. And activity E is cleanup and inspection. So the third column is your predecessor column. So we have A comes out of nothing, B comes out of nothing, C comes out of A, D comes out of A and B, and E comes out of C and D. Or you can say that nothing precedes A, nothing precedes B, A precedes C, A and B precedes D, and C and D precedes E. Okay? So the duration for activity A is 5 days. The duration for activity B is 7 days. The duration for activity C is 3 days. The duration for activity D is 5 days. And the duration for activity E is 2 days. Okay? In furtherance to that, you can look at your labor. Now, your labor is that activity A, you're going to allocate 2 laborers to complete that task. Activity B, you're going to allocate 4 laborers to complete that task. Activity C, you're going to allocate 3 laborers to complete that task. Activity D, you're going to allocate 3 laborers to complete that task. And activity E, you're going to allocate 2 laborers to complete that task. So therefore, to purchase and delivery of material, you're going to allocate two laborers for that. Removing existing tiles, 4 laborers for that. Installing new porcelain tiles, 3 laborers for that. Painting and installing new windows, 3 laborers for that. And clean up and inspection, 2 laborers for that. Now, in addition to this project, the contractor has decided that he or she is not going to use more than 6 days, 6 laborers on each activity, or 6 laborers per day. That means when he allocate the labor force for each activity, is not going to use more than 6 laborers per day for this project. So I am going to plot the diagram, calculate the critical path, and calculate the float, and from then we can show the duration of the project, and I'm going to show you now how you can allocate your labor force efficiently and effectively to reduce cost and also to complete the project on time. So in this portion of my presentation, I'm going to quickly plot this diagram, because in order to level the resources and level the labor force on your construction project, I need to know the duration of this project, as well as the float, as well as the critical path. So I have to calculate the duration as well as the float to determine the duration of the project and also the critical path. So let me quickly get into the calculation. So as it stands here, we have what is known as the project start. So this is an abbreviation of the table that I presented to you in the first part of my presentation. So if you notice very quickly, A comes out of nothing. That means nothing precedes A. B comes out of nothing. That means nothing precedes B. And then we have C comes from out of A. So C comes up out of A. So we're going to link C to A like that. And note the arrow. The arrow tells you which activity is coming out of which activity. Then we have D comes out of A and B. So we have A and B here, or we have D. So we link A to D and B to D like that. Right? And then we have E, which comes out of C and D. So we have C and D here and E. So E comes out of C and D. So we link C to E and D to E like that. Right? So let us quickly calculate the forward pass and the backward pass. I have already shown you how that is done in our previous example. So I'm just going to quickly go through this. So we have A, which has a duration of 5 days. So the early start of A is going to be 0. And 5 plus 0 is 5. So the early finish of A is going to be 5 days. So since C come out of A, the early finish for A is going to be the early start for C. So we'll bring our 5 right here. Right? C has a duration of 3 days. So it's going to be 5 plus 3, which is 8. Right? So the early finish, let me write this because we are going to need this information. So we want this to be shown clearly. So the early finish is going to equal to 8. Right? 5 plus 3 is 8. And then we come now, so we have B, which has a duration of 7 days. So the early start of B is going to be 0 days. So it's going to be 0 plus 7. 0 plus 7, which is going to be the early finish of B, which is 7 days, right? So we have D. D comes out of A and B. So we're going to choose, remember now when we are doing the forward pass, we choose the higher, and when we are doing the backward pass, we choose the lower. So the higher of A and B in terms of early finish is going to be 7, because A has an early finish of 5 days, B has an early finish of 7 days. So between the two activities, A and B, 7 days is higher. So the early start for activity B is going to be 7, right? So D has a duration of 5 days. So 7 plus 5, which is 12, right? So therefore, E comes out of C and D. So we're going to choose the higher of activity C and D. So C has a early finish of 8 days, and D has a early finish of 12 days. So we're going to choose the higher of C and D, which is 12. So the early finish of 12 days is going to be the early start of 12 days for E. E has a duration of 2 days, so it's going to be 12 plus 2, which is 14. So right there, we have calculated the duration of this project to be 14 days. But we have to do the backward pass because we have to know the float, because we are going to utilize the floating days to allocate our resources and level our labor force on the project. So we have to calculate the float. So the float is what we're going to use to level the labor force. So we're going to do the backward pass now very quickly. So the early finish of E is going to be the late finish of E, which is 14. Right? And we are going back, so we're going to subtract. So we're going to be, the duration of E is 2. So we're going to subtract 2 from 14, which is 12. Right? And since E come out of C and D, E comes out of C and D, so the late start for E is going to be the late finish for C, which is 12, and the late finish for D, which is 12. So we're going to have 3 from 12, which is 9, so the late start of activity C is going to be 9, and we have 7 from 12, 7 from 12 is going to be 5 from 12 is going to be 7. So the late start of D is going to be 7, right? So we come to activity A and B now. So remember now, D comes out of activity A and B. So the late start of D is going to be the late finish of A, which is 7 days right here. And the late finish of B, which is going to be 7 days right here. So we're going to have 7 from 7, which is 0. And we're going to have 5 from 7, which is 2. So we're going to quickly calculate the float. So let's bear with me. So we have 0 from 2 is 2, and 5 from 7 is 2. So A has 2 days float. Come to C, 5 from 9 is 4, and 8 from 12 is 4. So C has 4 days float. 4 days, 2 days. So we come to activity B, 0 from 0 is 0, 7 from 7 is 0. So activity B has 0 days float. We come to activity D, 7 from 7 is 0, 12 from 12 is 0. So activity D has 0 days float. We come to activity E now, 12 from 12 is 0, 14 from 14 is 0. So activity E has 0 days float. So right there, we have calculated the float, and we have also determined the critical path. So remember now, the critical path is the path that has 0 float. That means these activities on the critical path must be completed in the allotted time. As I have stated numerously in my previous videos. So our critical part is going to be B, D, and E, since the floating days on part B, D, and E is 0. So our critical part is going to be B, D, and E. So in my next step to this example, we also have to note that activity A has 2 days float and activity C has 4 days float. So we're going to utilize these floating days to level our labor resources. So viewers and subscribers, I want you to have a careful look at this chart or table which I have set up for you. So if you notice the chart on the extreme left, you have the activities A through to E, and if you notice on the right, we have days and we have laborers. So therefore, if you notice, we have the days goes up to 14 days. We have day 1, 2, 3, 4, 5, right up to 14 days. And the reason we have 14 days, you have to remember now that we just calculate the duration for this project to be 14 days. So let me just show you that quickly in case you're not following to the T. So if you notice, we calculate the duration of this project to be 14 days, and that is why we have the days numbered from 1 all the way through to 14 days. Now I'm going to take my time and fill out this chart and get into the leveling in terms of our labor force. So if you should look and remember the charts that I have given to you, remember now we are going to start with activity A, and we did say that activity A has a duration of 5 days with 2 laborers allocated to complete activity A. So it's 5 days. So we're going to count off 1, 2, 3, 4, 5, and each of those days we are going to have 2 laborers. So we have 2, 2, 2, 2. So that's 1, 2, 3, 4, 5. 5 days duration with each day which have 2 laborer for that 5-day period. Now we come to activity B. Activity B has a duration of 7 days. With each day we are going to utilize 4 laborers for that particular day. So activity B, we have a duration of 7 days. So we're going to count off 1, 2, 3, 4, 5, 6, 7, and it has 4 laborers for each of those days. So we're going to have 4, 4, 4, 4, 4, 1, 2, 3, 4, 5. So we have 2 more, 4 and 4. So 1, 2, 3, 4, 5, 6, 7. Right? So we finished with activity A and activity B in terms of duration and labor force. So we come to activity C now. But in order for us to fill out activity C, we know that activity C has a duration of 3 days, and we are going to utilize, the contractor decide to utilize 3 laborers to complete activity C. But if you notice, activity C, very quickly, activity C comes from out of activity A. Right? Activity C comes from out of activity A. Activity A finished 5 days. So that means activity C will start on the 6th day. So activity A finish in 5 day or the 5th day. So activity C will begin on the 6th day. So we turn back to our chart now. And if you notice, this is day number 6. So activity A finish on day 5 and activity C will start on day 6 with 3 days, with 3 laborers allocated for each day for activity C. So we go to day 6 and we put in 3 times. 1, 2, 3. So that takes care of activity C. We come to activity D now. So activity D has a duration of 5 days with 3 laborers to complete activity D. So we want to know when activity D starts. So we have to go back here, right? And we notice that activity D comes from out of activity A and B. So we have A here and B here. And activity D comes out of activity A and activity B. But activity A and B is going to finish in 7 days' time. So that means activity D is going to start in 8 days' time. So it's going to take 7 days to complete both activity. So even though activity A finished in 5 days and activity B finished in 7 days, cumulatively activity A and B together is going to complete in 7 days' time, even though activity A is going to complete in 5 days. So activity D is going to start on the 8th day, since A and B is going to finish on the 7th day. So we go back here. So we notice that activity D is going to start on day 8. Day 8, because both activity A and B finish on day 7. So activity D has a duration of 5 days with 3 day labor. So we're going to put 3 day labor for 5 days. So we're going to have 1, 2, 3, 4, 5. So that takes care of activity D. So we move to activity E now. Right? Activity E has a duration of 2 days, and we're going to use 2 laborers to complete activity E. So we have to go back to the precedent diagram to find out when we have activity E started. So activity E comes from out of activity C and activity D. So activity C finished in 8 days and activity D finished in 12 days. But cumulatively, activity C and D is going to finish in 12 days, even though activity C is going to finish in 8 days. But for both activities, they're going to both finish on 12 days. So if C and D finish in 12 days, activity E is going to start on the 13th day. So go back here now. So we move to the 13th day for activity D, and activity D has a duration of 2 days with 2 laborers for each day. So we're going to have activity E 2 times, so 2 and 2. So you see, comes back to our 14 days. So now we can total the amount of days or total the amount of laborer for each particular day, right? So we have for activity A, we're going to have 6 laborers, because we have 4 and 2 is 6, right? So 4 and 2 is 6. So for the labor row here, this row, which is the laborer's row, 4 and 2 is 6. 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 And 4 and 2 is 6. So for activity A, for day 1, we're going to use 6 laborers. For day 2, we're going to use 6 laborers. For day 3, we're going to use 6 laborers. And for day 4, we're going to use 6 laborers. And for day 5, we're going to use 6 laborers to complete activity A and activity B. Now, we come to this column now. So we have 4 and 3 is 7. 4 and 3 is 7. Right? We come here now, we have 3 and 3 is 6. Then we have 3 right here. 3 right here. 3 right here. We have 3 right here. And we have 2 in these remaining rows. Right? So let me give you the summary of this now. So on day 1, we're going to use 6 laborers through to day 5. On day 6, for day 6 and 7, we're going to use 7 laborers for each day for 6 and 7. For day 8, we're going to use 6 laborers. For 9 through to 12, we're going to use 3 laborers for those days. And for day 13 and 14, we're going to use 2 laborers each. But what you must understand, and if you go back to the beginning of my presentation, I did say to you that in order to minimize costs, the contractor states or come up with the idea or the notion that is not going to use more than 6 laborers per day. Right? The contractor come up with that and say based on costs and whatever factors is not going to use more than 6 laborers per day. But if you observe on day 6 and day 7, the contractor is using 7 laborers for these 2 days, which is 1 laborer over than the allotted amount that the contractor wants to use. So the contractor now will have to come up with ways and means how to bring down these 2 days here. Bring down these 2 days of 7 laborers, bring it down to 6 laborers because he don't want to use more than 6 laborers for any given day, and it's already over by 1 on these 2 days, day 6 and day 7. So in order to do that, and that is why it was important for me to calculate the float, the contractor now would have to look at the number of floating days he has. And floating days, as I said to you previously, are days that you can allow the project or that activity on the project to lag behind because those activity is not on the critical path. So the contractor will have to go back to the floating days, and what he observed is that activity A has 2 floating days. That means activity A can lag behind for 2 days before activity C started. So since he has 2 days to play with for activity A, the contractor can decide to use those 2 floating days. So we go back to A now, right? And we know that A has 2 floating days, but if you notice A has 2 floating days, but it is not affecting anything. So because the A stops right at this column right here at day 5. Right? But the activity that we want to adjust is really activity B. Right? Because these 2 days of 7 days here falls under activity B and activity C. So activity C, we know based on our critical path, has no floating days. So let us go back to the chart and see what's going on for activity B. Right. So activity B has no floating days, so he has to go to activity C, which have 4 floating days out of that. So he's going to borrow 2 floating days out of this 4-day float for activity C and level the labor chart. So it goes to activity B, because activity B, it goes to activity B because let's recheck that. Yes, it goes to activity C, sorry. Activity C, it goes to activity C because activity C has 2 floating days. So it's going to remove these 2 labor force here of 3 days and put it right here. Put those 2 days here. Right? So he borrowed 2 floating days from out of C. And remember now C has 4 floating days. So he removed the labor force and removed the activity from those 2 days here, day 6 and day 7, because you want to narrow this down. So if you notice now, the labor force for day 6 and day 7 will adjust down to 4. Because 4 here and 4 there. Right? And then the labor force for day 9 and 10 will increase to 6. Now, because this is going to be 3 and 3. So 3 and 3 is 6. 3 and 3 is 6. So therefore, if you should look at the row for your labor force now, you will see that with the exception of day 5, day 6 and day 7, which drop down to 4 laborers per day, and day 11 through to 12, which is 3 days, 13 and 14, which downs to 4 laborers, you will observe that no days you have more than 6 days laborers. So this chart basically it can be level some more if you want to, but this is supposed to satisfy the contractor, since on no given day is using more than 6 laborers to complete any task. So I hope you understand this exercise. This exercise is very, very critical because you can use it to cut back on your labor force to make your project more cost effective, because labor and material is what takes up most of your construction costs. So if you can minimize your labor force on your construction site, that is all good and well. So thank you for watching this video, and you know what to do already for those who have subscribed. And if you're watching this video for the first time, please remember to subscribe, hit the notification bell, leave a comment, and like the video. Thank you and take care.